Hi, my name is Wayne Odegaard with Aviation Laboratories, and today I'd like to go over the basics of TAN. So first of all, TAN. Total acid is really important when you're testing hydraulic fluid and oils because it's indicative of the quality of the fluid that you're using. If you have high acid in either oil or hydraulic fluid, you tend to have more corrosive activity in the system. Often the TAN is present because of water or some other breakdown of the fluid. So all of these things are indicative of the overall quality of the fluid. So we like to measure TAN, particularly in hydraulic fluid, we like to measure TAN. So let me go over the basics of TAN with you so that you see a little bit better how we do it. But to start, I'd like to talk about what TAN is in terms of the science of it. And basically, if you remember your chemistry, you know that there's a pH scale that goes from 0 to 14. A pH of 7 is considered neutral, so pure water will be a pH of 7. The lower the pH gets, the more acidic the fluid is that you're testing. The higher the pH gets, the more basic the fluid is that you're testing. What we're looking for is the acids in hydraulic fluid and oil. So if it has acid in it, the pH will be lower, and we're going to try to test it by adding a base to it that neutralizes the acid and raises the pH to a certain level. Now, what's interesting is this level, this 10 or so that we use. There's a family of chemicals that actually change color when they hit a certain pH range. In this case, we use naphthylbenzene as our indicator. We call that an indicator. And what we're doing is it's indicating for us when it hits a certain pH level. So if we add indicator to the solution we're testing and then add base to it, what ends up happening is as the acid is neutralized, the pH goes up, and when it hits this end point where the indicator changes color, we know that that's how much base was required to neutralize all of the acid. And from that, we can calculate how much acid was in the fluid. Okay, so let's talk about the actual calculation that we use for that. A TAN calculation, it's pretty simple. You have the required amount of base to neutralize the sample. You have the required amount of base to neutralize the blank. We'll talk about that in just a minute. So you subtract one from the other, multiply that by the dropper size. I'll talk about that in a minute too. And then we multiply that by the normality of the KOH, basically the strength of the KOH. KOH is the base, it's a potassium hydroxide. And we multiply that by 56.1. We get this number, 56.1, from the molecular weight of KOH. So there's our KOH, that's the molecular weight of potassium, that's the molecular weight of oxygen, that's the molecular weight of hydrogen. You add them together and you get 56.1. So we take the sum of this and we divide it by the weight of the sample that we used in the solution. And all of that calculation gives us a total acid number. So we can report TAN in terms of milligrams of KOH required to neutralize the acid in the sample. So let me show you in real life how this actually works. Now, I mentioned earlier that we have a blank. That was this B, the blank. The blank actually is this. Hydraulic fluid and oil are too viscous for us to titrate without thinning them out just a little bit. So we use what's called a TAN solution. TAN solution is just a solution made up of toluene, isopropyl alcohol, and distilled water. And we mix that together, and we use this as a diluent for the hydraulic fluid. So before we can actually titrate the hydraulic fluid, we have to titrate this so we know how much acid is in this. So the first thing we do is we use our indicator. This is indicator, it's in a little dropper. And these are calibrated droppers so that each drop is approximately equal to 0.05 milliliters. We'll put 5 drops of this in, 1, 2, 3, 4, 5. swirl it around just a little bit. I should put my glasses on. And then we're going to titrate this using potassium hydroxide, KOH solution. Now remember, this has some acid in it. We're trying to elevate the acid, raise the pH until it's high enough for the indicator to change colors. So let's see what that looks like in real life. Here's the KOH in a drop, calibrated dropper. We'll put 1, 2, I'm going to swirl it a little bit. 3. 3 drops changes that to blue. It's pretty cool, huh? How it goes from clear to blue like that. That's the indicator that's in there. And what we've done now is we started out down here somewhere and we raised it until the color changed, the indicator changed. Now we know how much acid is in this, basically 3 droppers full. So now we can take our hydraulic fluid. Again, we put hydraulic fluid in here. We put 10 grams of hydraulic fluid into the toluene, isopropyl alcohol, and water mix to thin it out. We'll add to this a few drops of indicator solution, swirl it around. You can see the color has changed a little bit, but that's just because the color of the indicator is kind of a brownish color. And now we'll titrate this with potassium hydroxide. So we'll put 1, 2, I'm going to swirl it a little bit. You can see it's starting to change colors, but it's not all the way there yet. 3, that's the color of the blank. So if it stayed at this endpoint, we would say there's no acid in there or negligible acid in there because 3 minus 3 is 0. But we're going to put 1 more drop in here. And you can see that there's the full color change right there. So this took 4 drops of KOH to get it to the endpoint. The blank took 3 drops of KOH to reach the endpoint. So if we look at our formula, we have 4 minus 3 is 1 times 0.5 times the normality of the KOH we used, the strength of the KOH we used, times 56.1 divided by the 10 grams of sample that we had in there, and our answer is 0.03 milligrams of KOH. The TAN, the number that we would report as total acid, is 0.03. So that's how we do it. Every lab does it like that. That's sort of the wet chemistry version of it. There's different ways that you can find the endpoint, but that's really how it's done. We use colorimetric analysis to do that, and we report the information as TAN. Thank you for tuning in. If you'd like to see more content like this, please subscribe. If you have any questions or comments, please leave them below. Thank you for watching.